Assalamualaikum and hello. My name is AZHARUL bin ASAN AZHARI. My matric number is 0749N30. You can call me ZAIM. And today I will be presenting our project for the subject CSD 33503 that been titled as Predicting Student Performance in Exam Using Clarification Technique. In this project, we focus on how machine learning can help the education system, especially by using existing student data to predict performance. Our goal is to help teachers identify students who may be at risk of failing so they can take action early and give the right support. These days, school collect a lot of data such as how often the student attend the class, how much they student and how well they do in the test. But most of the time, this information is not used to its full potential. Using data mining, we can find pattern and relationship that are not always obvious to teachers. In this project, we apply classification technique to predict whatever a student is likely to pass or fail based on their behavior and academic data. This can really help school take a quick action before things get worse. To reach our goal, we test the three classification techniques that are commonly used in education data mining. The first is decision tree, random forest, and lastly is a knife bias. These models are all different in how they work. Some are more accurate, some are faster, and some are easier to understand. We compare all three by looking at their prediction accuracy, how fast they run, and how easy they are to interpret. This helps us decide which one would be the most practical in a real classroom or a school setting. Let's start with decision tree. This model works by asking a series yes or no question, such as did the student study more than 2 hours or were there more than 5 absence. Each answer leads to another branch, which is until we reach a final destination, which is pass or fail. One of the best things about decision tree is that they are very to understand and explainable even to people without technical knowledge. In our project, it achieved 96.3 accuracy, which is excellent. However, the downside is that if the tree becomes too complex, it can start making error or new or unseen data. Random forest is likely a smarter or more powerful version of the decision tree. Instead of using just one tree, it builds many different trees and then let them all vote on the final answer. This reduces the risk of error and make the model more accurate and stable. In our project, it achieved 97.6 accuracy, which was the highest among all the three models. It works really well with messy or large dataset, which make it perfect for schools that have a lot of student data. The only drawback is that it's a bit harder to explain how the final result was made, since it combines so many trees. Now let's talk about knife bias. This model uses probability to make a prediction. It assumes that all input features are independent. For example, that study time and exam result do not influence each other. Even though that's not always true in real life, knife bias still perform really well. It's super fast and work great even with a small dataset. In our test, it gives 94.3 accuracy, which is pretty good. And it's kind of a good choice when you need a quick result or want to categorize students based on risk level. But compared to the other model, it doesn't give detailed reason for why the student is predicted to pass or fail.
Assalamualaikum, and my name is ZAIM bin Othman, and my matric number is 074926. So right now we're going to talk about pre-processing and feature selection, where is effective data pre-processing and truthful feature selection are critical steps in any data mining process. For education dataset, this step ensures the model is accurate, reliable, and interpretable in the real-world application, such as a prediction student performance. Right, for this part, we will be focused on data pre-processing. One most important step before building any prediction model, it involves 3 stages: data cleaning, encoding, and feature scaling. For the first is data cleaning. We fix any missing or incorrect value. For example, if the study time or grade column has blank, we can fill them using the average or the most common value. We also remove invalid data like negative grade, which will cause a wrong prediction. And next is coding category variable. Since machine learning model can understand whole like male or female, we convert them into a number. For example, like we use 0 for female, 1 for male. If a column has more than 2 categories, such as school name, we will use 1 or encoding so the very category has in all column. And finally, for the feature scaling, it helps to improve the model learning process. if we have too many unnecessary features, it can reduce accuracy or make a model too complex. So we focus only on the features that truly affect the performance, like student time or attendance, and we remove those that don't matter, such as how long students take to get school. So all ensure our data is clean, consistent, and ready for accurate prediction. Alright, next, impact of preprocessing and feature selection. Firstly, for the accuracy, the clean and relevant data lead to the more correct prediction. Example, if gender or test prep cost is encoded correctly, the model learn pattern better. So feature selection ensure the only meaningful inputs are used. So the result will be more accuracy when a prediction fails or fail. Next is for reliability. Preprocessing remove a noise, making the model behave consistently across the different data sample. It will avoid a random result caused by a missing value, inconsistent format, and unnecessary features. So the result will stay stable even on the new or unseen student data. And then lastly, for the interpretability, when features are well prepared and selected, the model become easier to explain. For example, math score is directly linked to the past. Educator can clearly understand why student flag is at risk. Using a fewer but important features also help the visualization. And then the results, stakeholder, teacher or admin can trust and act on the model inputs. Next is for the importance of preprocessing. First is remove error, where we handle a missing or incorrect value to avoid a model crash or bad result. For example, if student grade is missing or recorded as a negative number, we need to fix that before the training. Next, we ensure the consistency, where we fix an inconsistent format, for example, column, names, and date formats. This way, the system won't get confused by different way of writing the same things. Next is convert to a usable format, transform text, for example, that yes or no into the number, so model can understand it, to make the machine more readable. In short, without preprocessing, our data will be messy and the model would learn properly. So this step absolutely important. Next, important for a feature selection. So firstly is improve a model accuracy by focusing only on important variable like test score or preparation level. We remove a distraction from data that don't really affect the performance. Second is to avoid overfitting, where we reduce the noise and ignore unnecessary features, so the model become more general and perform better on the new data. And lastly is increase interpretability. That means it's easier for teacher, parent or admin to understand how the model came to a decision. With fewer, more meaningful features, we can explain the result more clearly. Okay, next, for the impact of preprocessing and feature selection. Firstly, for the accuracy, clean and relevant data lead to the more correct prediction. For example, if gender or test prep cost is encoded correctly, the model learn pattern better. For the feature selection, ensure that only meaningful inputs are used. So the result, the model will be more high accuracy. Next, for the reliability, preprocessing remove the noise, making the model behave consistently across the different data sample. Avoid the random caused by the missing value, inconsistent format, and then unnecessary features. So the result prediction will still stable even on the new or unseen student data. And then lastly, for the interpretability, when a feature are well prepared and selected, the model become easy to explain. For example, math score is directly linked to the past. Educator can clearly understand why student flag at risk. Using a fewer but important features also help the visualization, and then the result stakeholder can be more trust and act on the model outputs.
Next, to justify our model for the stakeholders, which is teachers and educators, the students and the parents. Here we will highlight 3 points, which is the use of interpretable model, share model performance metrics, and involve stakeholders in evaluation. Firstly, the usage of interpretable model. Will help the teachers to understand why this model are predicting the student to fail. By using visual decision paths, it will make the teachers to understand how this model to function, thus gaining their trust. Then, by sharing model performance metrics such as accuracy, precision recall, and confidence metrics, this makes confident that the model is reliable and data-driven. The involvement of stakeholders like teachers and academic advisors during testing will to validate results and give feedback, which will further improve the model to be better in. To encourage adoption, this model will not only give prediction, but it also can recommend action. For example, it will send alerts to tutors if a student is at risk, recommend remedial program for that particular student. This model can also be integrated into the existing system. Educators will be able to access this model through their existing e-learning system that they are currently using. Then, train the users. Conduct training session to staff to understand how to read the results and respond appropriately according to the situation. For ethical consideration, data privacy is play a huge factor in our ethical consideration. Student data must be stored securely and used only for approved academic purpose. Thus, we will use encryption where is possible. Then we also will use balanced and stable data set in order to avoid bias. Thus, to monitor model output for unfair patterns. And for purpose and use, this model should be used for support and not to punish students. This model are developed to be a support strategy, not an exclusion system. For the conclusion, this project showed that qualification-based predictive modeling can be a powerful tool in the education domain. By proactively identifying students who are likely to underperform, academic institutions can take timely action to provide support, allocate resources, and improve